Layering is a software architecture pattern that is used when the program has different levels of operations, where the high-level operations rely on the low-level operations. Layering is sometimes called n-tiered architecture. Many people use the terms interchangeably, but some use them to distinguish between a hardware separation among layers, as in n-tiered architecture, and a software or logic separation, as in n-layered architecture.
The layering architecture pattern can be tailored to include any type of layer that the developer believes is useful, but the four most common layers are the presentation, business, persistence, and database layers in that order. This figure shows those layers and how they are commonly implemented into software programs. The presentation layer is usually some type of user interface or GUI. For this example, it is the customer screen and the customer delegate. The customer screen receives a request from the user and sends it to the customer delegate module within the presentation layer. In this case, the customer delegate module knows which module to send the request to within the business layer and what information that module needs in order to perform the correct task. The customer delegate then sends the required information to the customer object within the business layer, which is used to aggregate the information that the customer is looking for and send the correct information to the next layer, which is the persistence layer. It sends the request down to the customer and order DAOs, or data access objects, which then sends SQL statements to the database layer to retrieve the information. That information is then sent back up to the customer object through the data access objects, and the customer object, or the business layer, combines the data and sends it back up to the customer delegate in the presentation layer, which then sends it to the customer screen module to be presented to the user.
Virtually all modern web applications are built using the layered architecture. This is largely due to the different technologies and programming languages that are used for each task. A graphical layer is typically developed using HTML, CSS, and JavaScript, whereas lower levels are often developed with other technologies, such as PHP. Furthermore, the database language is typically done in some form of SQL, or server query language. Any project that is significant in size and is likely to be maintained and updated can benefit greatly from a layered architecture. This especially helps in updates and refactoring, because as one part of the program changes, the implications on adjacent layers will be minimal and likely non-existent on more distant layers. In enterprise, software teams are often subdivided into more particular tasks. Separating the work of each group through a layered architecture is a natural way to ensure that the work of one group does not have to change because of updates made by another group. For instance, designers can work on and make updates to the presentation layer without cascading effects to the systems developed by back-end developers.
Layering is a powerful technique that can loosen the coupling between different parts of the application, allowing changes to be made to one section or one layer without significant effect to the other layers. Layering allows sections to be created agnostic of each other. For example, the developer of the graphical layer needs no working knowledge of how the database layer will be constructed. The code in the presentation layer can be written without any concern for how the other pieces fulfill their responsibilities. This is known as separation of concerns. The layering pattern is an easy one to visualize. This type of architecture allows the developer to be able to separate and organize different modules by the tasks they perform or by some other metric that makes sense for that program.
One surefire way to dismantle your layered architecture is to allow layers to communicate with layers that are not adjacent to them. It may seem faster for the presentation layer to communicate directly with the database layer, but it disables all of the benefits of employing a layered architecture for your software project. While layered architecture is widely used, it is not without its critics. According to prominent software engineer Mark Richards, the layered architecture pattern tends to lean towards tighter coupling and cumbersome builds, which leads to some of the pitfalls listed here. Tighter coupling makes it harder to change and adapt the software to changing environments. This also causes it to be harder to employ when one small change may mean deploying a large part of the whole program again. Using the layering program can also lead to inefficiencies in performance when more than 20% of the requests have to go through layers that simply pass the request to the next layer but don't do anything with the data.
One example of how layering architecture might be applied to our project is in meeting the filterable requirement described in section 3.3.9 of the SRS. The three layers would interact as follows. The presentation layer would display the elements based off of information received from the logic layer or the business layer about which elements passed the filters specified by the user. The presentation layer doesn't need to know anything at all about how the logic layer determines which elements to pass back to it. The logic layer would use the filters to determine which elements it would pass back to the presentation layer by requesting relevant information from the database layer. The logic layer or the business layer doesn't need to know anything about how the data is stored. The database layer is only concerned with how data is stored and retrieved. It returns the data that is requested, but it never knows or cares what is done with that data.
The layering architecture has upsides and downsides, just like any other architecture pattern. Although this pattern is easy to use and is widely adopted by industry, it can be used incorrectly. If this pattern is used incorrectly, it can cause the developers a lot of headache dealing with inefficiencies of performance and difficulties changing and deploying the program.
If anyone is interested in learning more, here is a list of some sources that we consulted while preparing this presentation. Thank you for watching.